So now let's do part B. So part B, the region bounded by this curve and the x-axis and the line x equals 1 rotated through 2 pi radians about the x-axis to form a solid. Okay, so this is a volume of revolution question. It's rotating about the x-axis. It's 7 marks, so it is going to be a big lots of maths involved in this one. Find the exact value. We need to leave it in terms of pi, in terms of ln and so on. Okay, so let's go. First of all, make sure you write down the formula for volume of revolution. It's rotating about the x-axis, so we're going to, the volume is going to be pi times the integral of y squared with respect to x. Okay. Now our y is ln of 3x over x. So ln of 3x over x. So then y squared is all of this squared which, when we square in ln of 3x, it's just ln of 3x all squared. Okay, it's not ln of 9x squared, or it's just that function there squared over, and then when we square x, we've got x squared. So our volume is pi times, the integral of this with respect to x, and then the limits, it's being rotated about the x-axis from 1/3 to 1. Now you need to make sure you write that bit down in the exam, because just writing that down is worth a mark. Right, there's a couple of ways to do this. We've got to do an integral. We've got different parts to it, so we're going to use integration by parts again. What I noticed when I did this is that this is very similar to this. The only difference is that this has just an ln of 3x in it, whereas this has an ln of 3x all squared. So what I chose to do, and again this is not the only way to do this, but is to do by parts, where I let one part be this and the other part be ln of 3x. Okay, so I'm going to let u be ln of 3x, so that I get u du by dx, or u dash. I've done it already, it's up here, it's 1 over x. And I'm going to let v be ln of 3x over x squared, so that when I multiply these two together, I get that, which is what I want. And the reason I've chosen to do it this way is because I already know what the integral to that is. Sorry, this is dv by dx, not v. And the integral to that is, I've worked it out up here already, it's this. Okay, so minus ln of 3x, oops, you can't see, minus ln of 3x over x minus 1 over x. And I'm just getting that result from my part A. Okay, so now let's do the integration by parts formula again. So I'm going to do, just going to not worry about the volume and things for now, or the limits. I'm just going to do the integral of this squared over x squared with respect to x. So I've got that times that. So don't be sloppy with your brackets. Minus the integral of that times that. Okay. So that's just the by parts formula. I'm doing this times this here, and then take away the integral of this times this. I've just written that first. Please don't be sloppy with your brackets. Okay. Right, so let's tidy this up a bit. Let's multiply this out. So I've got this times this is minus ln of 3x all squared over x, and this times this minus ln of 3x over x. Okay. This times this. First of all, I'm going to just deal with my signs. I've got a minus times a minus here, and a minus times a minus here. So this is going to, both terms are going to become positive. I'm going to put plus there. 1 over x times this gives me ln of 3x. Sorry, I don't know why I put that in bracket, but I mean x times x is x squared. And remember, we've dealt with that minus already, that's a plus because of this minus here. 1 over x times 1 over x is 1 over x squared with respect to x. And then what we have is we have this again. Excuse me. So we're trying to find the integral of ln of 3x over x squared, which we've already done in part A. I already know the answer to that. Okay, so nothing to stress over there. So we've got minus ln of 3x all squared over x minus ln of 3x over x, plus integrating this part first, just writing down my answer from part A is, you can't see anyway, it doesn't matter, just trust me, minus, this is the answer from part A for this bit, minus ln of 3x over x minus 1 over x. So that's that part integrated, and now I'm going to integrate 1 over x squared, and again I've done this twice already today. The integral of 1 over x squared is minus 1 over x. So that's minus 1 over x. Okay. So now I'm just going to tidy this up a little bit before I start putting limits in. I've got this term, this has got an x ln of 3x all squared in it, can't do anything with that. Over x. I've got a minus ln of 3x over x plus minus ln 3x over x, so that's minus 2 of those. And then I've got a minus 1 over x minus 1 over x, so that's minus 2 of those as well. Okay, so that's this integrated. So now I'm going to go back to my volume of revolution formula and start putting in these limits of 1/3 and 1 and sticking this pi in as well. So I've got that V, the volume, equals pi times this all squared over x minus 2 ln 3x over x minus 2 over x between the limits of 1 and 1/3. Okay, so now let's put these limits in. Okay, putting the 1 in first. So I've got ln of 3, because when x is 1 I've got 3 times 1 there, all squared over 1 minus 2 ln 3 again over 1 minus 2 over 1. Okay, that's your first subbing in. Take away, and let's now put in this third, and this is when things start getting a bit nicer, because when I've got ln of 3 times 1/3 I get ln of 1, and ln of 1 is 0. But let's show the examiner that we know to do the substitution. So 3 times a third all squared over a third minus 2 ln 3 times a third over a third minus 2 over a third. Okay, so I have pi. This bit is just minus ln of 3 squared, and again that's not ln of 9, it's just ln of whatever ln of 3 is squared. These are all over 1, so these are just what they are. Okay, and then over here, ln of 3 times a third, like I said, that's ln of 1, and ln of 1 is 0. So that term goes. Same thing happens here. That term goes. The only one I need to worry about is this. 2 divided by a third is 6. So I've got minus 6. So I've got plus 6 here. And then the only thing I need to tidy up is this minus 2 plus 6. So I've got pi times minus ln 3 all squared minus 2 ln 3 plus 4. Done. 7 marks.